Okay, we're going to get started with our first flash talk. With me today is Yuxing Chen from UW-Madison Food Science. Take it away.
Thank you. All right. Can everybody hear me? Okay, never mind. It's only front person. So for cheese board, it has been long used in the cheese ripening process, and it's very popular among artisanal cheesemakers due to its porous and hygroscopic properties. And right now, there's accumulating observations that those cheese board actually have antimicrobial effect against foodborne pathogens, especially Listeria monocytogenes. So in my study, I want to see whether this bacteria from those cheese board surface actually inhibit Listeria, and if so, what's exactly the inhibition mechanism of that? So first of all, we harvest 10 cheese board from 3 different cheesemakers in Wisconsin, and then all the cheese board that we receive, actually we can see a circular cheese zone where the cheese block was placing in the cheese ripening process. So in the following up analysis, we try to separate the clear zone from the cheese zone to prevent the confounding presence of the cheese rind bacteria. As you can see, either from different cheesemakers or the same cheese board from different sections, they have a diverse microbiota composition here. And then from that on, we want to see how Listeria behave on those cheese board surfaces. So previously, the recovery of Listeria on cheese board surfaces is notoriously poor. So we want to have a method that can keep track of Listeria population over a prolonged incubation time. So we developed a disruptive grinding method that keep track of Listeria population over 20 days. I don't know why the slides look like this, but then Listeria does decline on the clear zone of the majority of the wooden board that we assessed, but Listeria does replicate on some cheese zones when we can see the visible cheese were left. And then at the same time, want to isolate some cheese board bacteria that inhibit Listeria. So in the end, we isolate about 54 isolate, and they belong to 7 species, such as Bacillus staphylococcus, Serratia phyla, as well as Lactococcus lactis. And then following up, we focused on Bacillus staphylococcus as a novel biocontrol agent candidate, and we found out that Bacillus staphylococcus can secrete antimicrobial peptide into the environments that inhibit Listeria. So at the same time, we want to see how Listeria responds to those inhibition. So we did RNA sequencing, and we find out that with a sub-inhibitory concentration of Bacillus supernatant, Listeria actually has a significant increase of stress response. And in general, our project suggests that the wooden cheese board can be a rich resources of antimicrobial producing bacteria, and it could have potential applications in novel antimicrobial discoveries.